all the negative numbers?
You left it sitting on the table.
Yes, you did. You did. You got that somewhere. Do you have the answers to the
I have one right here.
Miss McGee.
I don't know if I feel like
Let's do a couple of them together.
I need 3, 4.
2, 3, what'd you say? Let's go 4.
I need 2, 3, 4, a lot of them, but 4 is
Oh my gracious.
I
Okay,
got these all wrong.
4.
Can you post the answers?
Well,
Just going over the answers right now.
I will though. I'll work
You
them
done
out.
enough for us.
Thank you, Emma. You're so sweet, but I will. I know you did, and you know what?
What did you do?
I was already home, and I tried my very, very best. No offense to everyone. This is something that took me a lot of years to come to. When I leave school, I try to leave school, and I try to denote that time for my family. So I don't pull my computer out. So if it's something I have to pull my computer out to do, I probably won't. I'm sorry.
So if we email you and it's like urgent, you're not going to answer.
If it's urgent, yes, and I'll respond to an email, but if it's something I actually have to pull my computer out and do work for,
I'll just text your daughter and be like, tell your mom I need this one.
or if you need like help with something specific, I'll usually answer. But as far as like taking my work home, like I usually
Grade at home.
And that's
I don't write at home anymore.
like
Well, this is called properties of excellence.
We've been Russell and I have really been working on work-life balance and putting priority on family as opposed to priority being on work. So that's where we are. Anyway, enough of my little soapbox. Hey, Wyatt, number 4. Is that what you're asking me for? Okay. All right. So if I'm looking at this one, I'm thinking, okay, I've got some external exponents here that are on the outside of the parentheses. So I know that it can go to the top and the bottom of a fraction. Now again, you might work inside the parentheses first, and that's okay if you did. Is that what y'all did? Inside first?
no, I didn't.
You did there. Okay. So I would probably look at this one and say, okay, I'm going to take, this is a power to a power, which I do what with? Multiply. That's right. Times them. So what did you do then?
I just did -4 times the inside, and I did -1.
Well, that's what I was asking. So you work inside the parentheses first.
That was my problem. Like, whenever I did -4 times 2, it just gave me a fraction.
Yes.
I'll do
So, but keep it, because remember, what does a negative exponent do?
It's
One of
imaginary.
those properties. It flips, so it's really 1 over 2 to the 4th. That's why you got a fraction.
Wait.
If you distributed that -4 through, and you got this, that's really this. 2, 4, 8, 16.
So we just end up moving the 2 down.
So because there's some more 2's and stuff here, I would just leave it as is right now, and then I'll show you how to deal
We
with
end
it.
up moving that 2 down and 2 on the bottom up.
Yes. Yes. All right, so I've got here 2a to the 4th, b to the 4th, c to the 2nd. I do have you more practice with this, a couple problems tonight. A, B, -4. There's this multiplication sign which tends to throw students, but really there's a multiplication sign in front of all of these, in between all of these numbers and variables, because that's the implied operation here for all of these. So times 2ab squared, and then now I have this -1 that's going to sit out front of that denominator, or outside that denominator. Does everybody see where that step came from? Now I'm going to start working inside some. So maybe I take this exponent to everything. Well, now Wyatt, I don't have a -4 anymore because I multiplied the 2 negatives together. So I have 2 to the 4th, a to the 16th, b to the 16th, c to the 8th, over. And now I'm going to do the same with the -1. A -1. -1 times 4 is +4. 2 -1. A -1. B -2. Before I start moving stuff around and subtracting it, I'm probably going to simplify the numerator and the denominator if I can. And to do that, I'm going to look at what has the same base. Same base. Same base. So I would have, and I'm going to leave this up top. Some of you were simplifying that to 16, and if you I'm simplifying the bottom. I'm going to combine those ones that have the same base. So what is negative 1 plus negative 1? Negative 2. What is 4 plus negative 2? And then I still have this 2, negative 1 here.
So how would you
How
end up
would you
losing
just
that
put them
2
down?
negative 1?
You could. That's not wrong. And that's the point that I'm kind of making is you might do it differently than I do, but we should, as long as you follow legitimate rules, we should end up back at the same place. Why what?
So we just end up having 2 to the 5th of the top.
That's correct. That is correct. So I'm going to go ahead and move my negatives now. I'm going to move this one up and this one up. If there were any negatives up top, I would go ahead and move them to the bottom. So what I have is 2 to the 4th, A to the 16th, B to the 16th, C to the 8th. But these 2 negatives come up and become positive. And it only leaves me B to the 2nd and the bottom.
Would it work? I didn't do that, but like, would it work if you did like A16 minus
Negative 2?
so that'd be
Yes.
18?
So it'd be 18. And that's going to be up top. You're going to still get the
Wait,
same
how
thing.
would it be to the fourth?
How would that be the second
That's a
still be
16,
down
so.
there?
Say again?
Wouldn't you end up moving that up to
Mhm.
make it to the A16, B14?
Yes, yes. I'm just trying to go with just one little property at a time so you see. Up top, I'm going to go ahead and combine what I can. So I've got 2 to the 4th and 2 to the 1st, which would be 2 to the 5th. My A's, I have 16 and 2, which would give me 18. And my B's, I have 16, and then I have a C to the 8th. And it's all over B to the 2nd. And now I can subtract those B's, right? What's 16 minus 2? Thank you. 14, C to the 8th. So even if you did things a little bit differently, you should have come back to the same thing. If you have 32 instead of 2 to the 5th, that is okay too.
Oh, I did it way wrong.
Yeah, I was like slightly off.
You do have 32. You do more than
Yes. We were a little rushed with it yesterday.
Yeah, because we didn't get it like
Give me another one.
you do 3.
This is literally as hard as they get with these. These are some of the harder ones.
I didn't know what I have on 3 of them.
Okay, so let's do it. 2y negative 2 times. Again, the times is really redundant here, but that's okay. So, let's do this one a different way than what we did the other one so you can see that it doesn't really matter as long as I'm doing legitimate things here. In fact, I think what I'll do is I'll work inside instead of taking that through and start doing some stuff. I think I'll move all my negatives around. I think I'll move that one down, and that one down, and then I'll move this one up. Now, you could subtract here like you were doing before, and you could say negative 2 minus negative 1 and whatever if you wanted to. You certainly don't have to. Let's see. Up top, so if that 2 is still there, then I have that one's moving to the bottom. That 2 is still there.
Wait, you leave the 2?
Yep, because those are separate pieces. It's 2 times y.
When is it like connected, like you were doing yesterday? When it was like when they're all the same, you just have the. You did something where it was like all the.
Wait, would you also put it in 2?
Hold on just a second.
Like you did something yesterday where like all the variables were the same, so you just added the coefficients or whatever. Or was that regular?
So I think this if we were adding or subtracting, we combine the coefficients in front. But if we multiply,
Okay. I think that's weird.
I think I was just showing you the difference there. Let's see what else. I've still got the 2. I've got that y and that z are coming down, but this y is coming up. And then on the bottom, the x cubed is still there. The y squared came down. The y cubed comes down. The z squared comes down. I still got a negative 2 on the outside. Does that answer your question, Miguel? So this is 2 to the 1st times 2 to the 1st. If you put if you put 4, or if you put 2 squared, either one of those are acceptable. I've got y, and now I'm gonna just clean up on the bottom because I've got x to the third, y to the fifth now because I have these 2 y's, z to the second, and now I'm gonna simplify that fraction inside. 2 squared. 1 minus 5 is what? -4. When you subtract, it always stays in the top. We can move it later, but when you do the subtraction, you keep it in the top. And then I got x cubed, z squared, and then I have -2. This might have been a little bit longer way to do this one. X, y, z. That pesky -2 is still on the outside there. So
Wait, why is that why is the -4 turned into a 3?
I don't, because I messed up. I'm sorry. Now the -2 goes to everybody inside, right? Am I multiplying or adding with the exponents here? Multiplying, because it's a power to a power. That's exactly right. So I get 2 to the -4 over. When I say everybody, it's going to everybody, because there's nothing but multiplication and division in it. So x -6, y -8, z -4, and let's move some stuff around. All the bottom comes up, all the top comes down. I get x6, y8, z4 over 2 to the 4th, or 2, 4, 8, 16. Either one's fine. That's your answer. Yes.
You want us to do it? Does it matter like on the order or like variables or whatever? Like does it need to be like x, y, and z?
Oh, it doesn't matter. That's just pretty math. But it won't matter.
I'll put 60 instead of 2, so
That's
that's fine.
fine.
You do 9.
9?
And then you do 10.
Okay. Number 9. Again, y'all, these are hard. They won't get any harder than this. This is, yeah. Times 2p -1 q3. I'm going to clean up inside first. This looks very similar. I think I'll distribute the -4 here first.
Yeah. That way we don't have enrichment.
What?
Kyle's not here.
It depends on if they say enrichment canceled. -2 times -4 is 8. And then 0 is still there. And I could take that off if I wanted to. It's really not impacting since I'm multiplying, that's 1. Times, and then I've got 2p -1 q3. I'm just going to rewrite all this. 2qr, everything 2. Clean it up just a tad, and I have,
Wait, could you do like the 2 times -4 and then distribute and then do 2
yes,
times?
yes, you certainly could. Q8 and Q3 would give me Q11.
Wait, you just add those stuff?
Yep. Because I'm multiplying, so all you have to do is add the exponents, not the coefficients.
What do you do with it? I would say the same.
The 8 and the 3. Yeah.
Why don't you
-4.
Because if I have
Isn't that
2 to the
-5?
5th
Oh,
times 2 to the 7th, you can't call that 4 to the 12th. You can't multiply the coefficients and add the exponents. It doesn't work like that. So, but that's a common mistake. So did everybody hear that? Be very careful. You can't multiply coefficients and add their exponents. You're giving it way too much. So keep the base. Leave the base alone. Because remember those 2 things I wrote yesterday? When you're multiplying, leave the base, add the exponents. When you're adding, combine the coefficients and leave the exponents. It's different, and it starts to get confusing. That's why I told you write that down and reference that, because it does. Okay. I'm gonna move. So I get Q11, 2 to the third, 2 to the first. The QR is there, and then I need a P on the bottom. And so I get 11 minus 1 is 10.
Hold up, come on.
Okay. Go down or slow down? Two to the fourth. This one had a 1 and then I put a 1 there.
That's just 16.
And you can just put 16 if you want. I waited until I had all of my 2's together. Now I'm just going to double all the exponents.
Wait, don't you have to move that Q up?
It's a positive. Oh, you're right. It's gone. Sorry. I subtracted, but I didn't. You're right. Q20 over 2,8R2 P2. Sounds like Star Wars.
What would 2 to the 8 be?
2, 4, 8, 16, 32, 64, 128, 256.
That's the same thing as 16.
Q to the 20.
What'd you say? What X would be? 256. That's what you got, Ellen? Yeah. Is that what you got?
Where did the Q, what?
I
got it.
64 or something.
What?
I know I got 10 wrong because I got H to 17.
No, like, I'm doing
I got H to 13. No, that's right. I don't know how I know. I should have gotten somebody else.
It's easy, but it's easy to get lost in your work too.
Because if you do one thing wrong, then it's just all wrong.
This is 10.
Let's say 18.
I'm going to do this one, then we're going to step away from this for a minute, and then I'll try to do some. Yeah. I know. All right. I'm going to clean up the top a little bit, combine what goes together. So I have 2 2's. I have H and H to the fourth, which would give me H to the fifth. I have J to the fourth and J to the negative 1, which would give me J to the third. And I have K to the second and K to the first, which would give me K to the third. On the bottom, I'm going to go ahead and distribute this exponent through to everything. So I have 2 to the second, J to the second, H to the negative 8, and K to the 0. Because these 2's are exactly the same, I'm going to cancel them out. 2 minus 2 is 0. 2 to the 0 is 1, so I'm good there. And I think, just to show you that this works, before I move anything around, I'm just going to subtract them as is. So in other words, H, 5 minus negative 8 is what? 13. Because 2 to the 0 is 1. If you subtract those, and it cancels. If you have the exact same thing on the top and the bottom, you can cancel. As long as you're multiplying.
this paper is like gone.
I got 3 J's up top, 2 in the bottom. That leaves me 1 up top. I have 3 K's up top and 1 in the bottom. That leaves me 3 up top. So H to the 13th, J, K, Q.
I got H to 13, K cubed over K cubed. For some reason I got H to 17.
Wait, there was a 2J. I had a 2J on top.
I got H to the.
Unless I copied
No,
it
you
wrong.
did. 17 was pretty.
All right, if you needed monomials yesterday, and what did we say monomials were?
1.
1. polynomials is the only operation you can have with the exponents is multiplication. It is only one term, hence monomial. What does poly mean? What does the prefix poly mean?
Many.
Many, right? Poly means many. So a polynomial, many nomials or many terms. And in fact, it's any number of terms. Terms are separated. You gotta keep them separated. Nope. Y'all are too young. Do you really?
Yeah.
I sing that every year and nobody has ever heard it. You really do?
Yeah.
What?
He's just saying that. Which
I
one?
do know that song.
Oh, you gotta keep them separated. Okay. In fact, one year they argued with me so much that I pulled up the song to play it, but it's not. I just remember it from high school, so I didn't remember it had it.
No, Ellen, I do know that song. Probably in an 80s.
All right.
He's just saying that.
One or more terms is a polynomial. So a monomial is a type of polynomial. But the polynomial is the overarching type, okay? So one or more terms here. So when we are in standard form of, well, actually, let's define polynomial first, besides one or more terms. All exponents must be positive whole numbers. Otherwise, it's not a polynomial. So if I had something like that is not a polynomial because this exponent is negative.
But like the coefficients, where like the 2 and the 6 could be like negative.
Yes, coefficients don't matter. They can be anything in the world, but the exponents have to be positive whole numbers. We generally will write polynomials in standard form, and standard form just means, did I not? I think I did.
Like, so -3 would be a...
This is not a polynomial because of the -3. Standard form is whenever I write it in order of the exponents. So from the biggest exponent to the smallest. And y'all are used to that. We did the quadratics, right? Where we did the ax squared plus bx plus c. So with a polynomial, we start with the biggest exponent and we just work our way down. The biggest exponent, let's see. Two things about polynomials. The biggest exponent in a polynomial is called the degree. So what is the degree of a quadratic? 2. That's the biggest exponent in a quadratic equation, right? 2. So whatever that biggest exponent is, that's the degree. And when we're written in standard form, this makes a little more sense, but the coefficient with the degree term. Do you know what that's called? This is really wordy. This is the notes part before we get to the application part. If it's hooked to the degree term, the degree is the biggest exponent, then it leads the equation when you're in standard form, so it's called the leading coefficient.
That's just the coefficient or
Just the coefficient, yeah. All right, let's talk about adding and subtracting polynomials. Well, actually, before I do, we talked about terms. Terms are monomials that are added together, right? They're the pieces of the polynomial equation. So whenever I say like terms, tell me what that means.
So we're going to add and subtract.
Right. What's the same? Like y'all heard combine like terms all the time. What are exactly like terms? The same letter, which is the variable, right? So I'm going to say the same base or variable. What else has to be the same? Does the coefficient have to match to be like terms? The exponent has to be the same. Give me an example of two like terms. 2x squared and 3x squared. Those are like terms. Give me another example of two like terms.
X cubed and X cubed.
How about
She's not wrong.
She's not wrong. 7x to the fifth and negative 12x to the fifth. Like terms or not?
Yes.
Yes. Now, when we combine these like terms, which you've done before, and we've definitely done it with powers of 2, but when you combine these like terms, how do you do that? Add what? Just the coefficient. We only combine the coefficient or coefficients. Leave the exponent alone. Yes. 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 Got that? So how would I add or subtract a polynomial? So we talked about what makes it a polynomial. We talked about the parts of a polynomial. We talked about combining like terms. But what if we have entire polynomials? For example, what if I had 3x squared plus 11x plus 4 plus x squared minus 5x minus 13. Those are both polynomials. Agree or disagree? Agree. Okay. So I've got this, by the way, has 3 pieces to it. So this is called a trinomial. 2 pieces is called a binomial, and 1 piece is called a monomial. What's the degree of that first polynomial? Yep. What's the leading coefficient? 3. If I want to add them together, any ideas what I'm going to do here? Combine like terms. That's all you do. This should be super duper easy. I will sometimes circle the ones that go together, make different shapes over them so I keep track of what I have. I've got 3x squared. Notice the operation in the middle is add. It's not subtract, so I'm just adding the coefficients here. Plus x squared gives me what? 4x squared. So notice I'm combining the ones in front. I'm leaving the x squared alone. All right? Then I've got 11x and negative 5x. What does that give me? Positive 6x. And then my constants here on the end, I have 4 and negative 13, which gives me negative 9. I get a polynomial back out. In fact, it's a trinomial. What is the leading coefficient? What's the degree? Everybody good? What if I had changed this from addition to subtraction? In other words, I have 3x squared plus 11x plus 4. That's exactly right. Minus x squared minus 5x minus 13. Because I'm subtracting everything in that parentheses that follows the subtraction sign, I need to make sure if you're a same change kind of person, I change this, but I change every single sign inside the parentheses. Now it's just an addition problem. Yep. That's usually the easiest way to do it.
Can we do one on the homework?
Which one?
Okay, most of them will.
Okay, well hold on because we haven't gotten the multiplication and
Or
division yet.
13.
Let me run you through multiplication real quick, and that's where we're going to stop, and then I'll go through and work if we have time with any of those. When you multiply polynomials, I am going to assume, and you tell me if I'm right or wrong, have you all FOILed?
Yeah.
Okay. When you multiply terms, in other words, if I do 3x squared times 5x to the 5th, how do you do that? What do you do? Multiply the coefficients, add the exponents, right? Well, this isn't FOIL, but multiply coefficients, add exponents. This is kind of what we did yesterday, because remember, there's implied multiplication there. So it just multiplied the numbers that went together, and then the ones that had the same base, I combined those exponents on. Now, the problem comes in, what if I have something like so you learned FOIL. FOIL only works with two binomials, whenever it's two pieces. But if I have more than that, FOIL goes out the window. So I like to teach you with what I call distributing. Not today. I'm going to distribute everything. Okay? What I mean by that, start with the first term and distribute it to everything in the second set of parentheses. What is W times W squared? W to the third. Distribute it to the next piece. What is W times 2W?
Wait, this isn't multiple.
Yeah.
2W.
W times 1. It's easier, but we're going to have some that'll be like 4 and 5 and 6 piece polynomials times others. All right, so now W has multiplied to everything, so I'm done with it. And now I move to the next term. And now I bounce that one to everything. So negative 7 times W squared. And now I clean it up. So now I can just combine like terms. W to the third. I have 2W squared minus 7W squared, which leaves me with what? Negative 5W squared. I have W minus 14W. Leaves me minus 7. What's the degree? Leading coefficient? 1. Good job. 1. All right, a couple things too before I set you loose to warn you about. Number 1, if you multiply more than 2 things together, so in other words, if I have something like number 16, I'm not going to do this one for you, but I want you to try it. But if I have something that looks like this, I never multiply more than 2 at a time. Don't bounce this to everything. Do the first 2, get an answer for that, and then multiply it to the last piece. Okay? Don't do more than 2 at a time. You will not get the right answer.
What
if it's like 15? Do you do like the last two and then?
Whichever you want to do first. You can do the negative 3x to the first parentheses and then multiply it, or you can multiply the two. You can multiply any two you want together first before you multiply to the third.
So can we not do 19? Or like, do the
Okay, so
19?
19 and 20, let me explain those to you because those are a little
Good
different.
morning, Camden High. Please stand for the Pledge of Allegiance. I pledge allegiance
To the flag of the United States of America
and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please be seated for a moment of silence. Attention any 11th grader. It's time to sign up for the PSAT to be given on Tuesday, October 25th. Keep in mind that the PSAT enables you to practice for the SAT test, seek information from colleges, enter scholarship competitions, and get feedback about your academic progress. It is strongly recommended that you have taken Algebra 2. The cost is $19. Please bring a check payable to Camden High or cash to Ms. Atkinson and guidance by October 18th. The ASVAB will be given at Camden High School on Thursday, September 22nd. See Ms. Atkinson in the guidance office to sign up to take the ASVAB. This will be an online assessment and is limited to 30 students. Attention all students, are you ready to dance? Student Council will be hosting a homecoming dance on Saturday, October 1st from 7 to 10 in the gym. The cost is $10. You can sign up in the library starting this Thursday.